Hi everyone, my name is Pam Soto. I am part of the DPT class of 2019 at Regis University. The title of my poster today is Effects of Muscle Fatigue During Isometric Contraction on Muscle Motor Recruitment Amplitude. EMG is often utilized to measure action potential generated in muscle during motor unit recruitment, as it is reliable, cost-efficient, and easy to operate. Motor unit recruitment has been shown to increase during onset muscle fatigue in previous experiments. The purpose of this experiment was to analyze the responsive amplitude during the onset of muscle fatigue. We hypothesized that EMG amplitude would increase with onset of muscle fatigue. To test our hypothesis, 8 healthy subjects were selected, 6 males and 2 females. Every subject had their arms shaped at the muscle belly of the wrist extensors and flexors. We used a two-surface EMG. Channel A was attached to the muscle belly of the right wrist extensors, while channel B was attached to the muscle belly of the right wrist flexors, and our ground was attached to the bicep muscle. We then, using a hand grip dynamometer, calculated the maximum voluntary contraction. Once we did, from that, we calculated 25% of MVC, which was to be held during the duration of our experiment, which was up until muscle fatigue, or 300 seconds. All of our peak force, peak EMG for extensors and flexors, and our target force of 25% of maximum force are shown in Table 1. As you can see on our results, we have figure 1 and 2, which show our extensor and our flexor data. On our x-axis for both graphs, we have time measured in seconds, and on the y-axis, we have our amplitude measure in standard or percent standard. As you can see through the duration of the experiment, we have scatter points. To these scatter points, we also added error bars, and then a trend bar was added, shown in red. As we go on, our trend bar shows how instead of increasing our motor unit recruitment, our amplitude actually decreases. So our findings do not support our hypothesis. We can infer that some source of error could include electrode placement, tester error, force wasn't kept consistent, and experiment didn't run long enough to cause muscle fatigue. Some of the clinical relevance for this experiment could be that EMG is a very helpful tool to diagnose, treat, and monitor patients' progress. Therefore, it is vital that accurate EMG equipment, protocol, and data interpretation be followed. Thank you for your time today. Appreciate it.